Alright, welcome back to Mathemagical Learning. And today we're going to be doing question 3 of SMO Junior Special Round. Okay, so feel free to pause now if you want to try and solve it on your own. Alright, so we have got the problem and it says, given that these numbers are integers, find all possible values of m and n. Alright, so how are we going to tackle this problem? So over here we've got m and then n at the bottom and n and m. If only we could add or subtract so that we can just have one number to work with. Two numbers to work with is rather complicated. So if the two numbers are integers, then the difference between them are also integers, right? So we have 2m minus 1 over n minus 2n minus 1 over m. That's an integer as well, right? And now what can we do? Now we can just make the common denominator. So we have mn, m squared minus m. We multiply m on the top and bottom, and multiply n on the top and bottom, and we subtract. So we have 2m squared minus 2n squared minus m plus n over mn. So now let's check. 2m squared minus m, yep, and minus 2n squared. Okay, so we can use the difference of squares formula, and we have 2 m plus, or rather, 2 m plus n, m minus n, and notice that this is negative n minus n, minus m minus m. Now over mn, this is equal to 2m plus 2n times m minus n minus m minus m all over mn. So this, we can factor the m minus n, and we have m minus n, we have m minus n 2m plus 2n minus 1 over mn. Okay, now we are going to assume that n is greater than or is less than or equal to m. Okay, without loss of generality, it could be either way. So since this is an integer, n, or rather, m must divide this expression, but n minus n is less than m, so m cannot go into m minus n, so hence m must go into 2m plus 2n minus 1, right? So 2m plus 2n minus 1 is congruent to 0 mod m, because it's divisible by m. So since this is divisible by m, we can cancel it out, and we have 2n is congruent to 1 mod m. Okay, so now we know that 2n is less than or equal to 2m. So that means 2n cannot be equal to 2m plus 1. So basically this means that 2n is equal to km plus 1. Then that means k is less than 2. So k could be 0, in which case n would be 1/2, but n is an integer. So this is impossible. So k must be equal to 1. So we have 2n is m plus 1, or n is m plus 1 over 2. Substituting back into our original equation, we get 2m minus 1 over n is an integer, which is equal to 2m minus 1 over m plus 1, and then multiply by 2 on the top. So we have 4m minus 2 over m plus 1, that's an integer. So we have 4m minus 2 over m plus 1, integer. And so that means m plus 1 goes into 4m minus 2. And so we can multiply by 4, and we have 4m plus 4 is, so we know that m plus 1 goes into 4m plus 4, and we can take the difference, so m plus 1 goes into 4m plus 4 minus 4m plus 2, which is equal to 6. So m plus 1 is a factor of 6. And remember, m plus 1 has got to be even, because m plus 1 over 2 is also even. So m plus 1 over 2 is an integer, so m plus 1 must be even. So m plus 1 could either be 6 or m plus 1 is 2. If m plus 1 is 2, then so that means m is 1, n is 1. So 1, 1 is a pair. And if m plus 1 is 6, then m is 5 and n is 3. So 5, 3 is also a possible solution. So the solutions are 1, 1 and 5, 3. But remember, there could be non-integers whose differences are integers as well. So we have to check in our original equations. Obviously for 1 and 1 it works. It would just be 2 times 1 minus 1 over 1 and 2 times 1 minus 1 over 1. So that works. And for 5, 3, we would have 2 times 5 minus 1 over 3, 2m minus 1 over n, and 2 times 3 minus 1 over 5, that's 2n minus 1 over m. Alright, and this is 9, so that 9 over 3 is 3, that's an integer. This is 5, 5 over 5 is 1, that's an integer. So the only solutions for this equation are 1, 1 and 5, 3. And that's it. So thanks for watching. If you liked this video, don't forget to like and subscribe and share the video with your friends. If you want to receive notifications for more videos like this, you can always press the notification bell. As always, thanks for watching.